Good afternoon, everyone. So in today's lesson, we will learn about concentrations of solutions with Ma'am Kamila here. So what is concentrations? Concentrations of solutions is a measure of the amount of solute that has been dissolved in a given amount of solvent. I'm sure that we already talked about this in the last meeting. Concentrations of solutions can be expressed in other ways, such as percent by volume and percent by mass. So what is percent by volume? Percent by volume is the amount of solute in a given volume of solutions. It is expressed as grams solute per 100 milliliters of solutions. It will be expressed as grams per 100 milliliters. You can see there is a formula to calculate the percent by volume. So percent by volume is equals to volume of solute in milliliters divided by volume of solutions in milliliters times 100. So here is the example. I have 100 milliliters of hand. In this packaging says it has 70% of alcohol. It means in this hand sanitizer, it contains 70 milliliters of alcohol inside 100 milliliters of hand sanitizer. Let us move to percent by mass. Percent by mass is the given amount of solute in a given mass of solutions. It is expressed as grams solute per 100 grams of solutions, or grams per 100 grams. Percent by mass also have a formula. So percent by mass equals to mass of solute in grams divided by mass of solutions in grams times 100. Let's move to the example. So I have this bleaching product. I'm sure that some of you have it in your house. This is a quiet, ordinary bleaching in the Philippine household. So this product brand is Clorox. So this ordinary bleach is containing 5.25% of sodium hypochlorites by mass, which means each 100 grams of bleach containing 5.25 grams of sodium hypochlorite. Next, let's learn from Phet Colorado. So this is the virtual labs that I will introduce to you. Good afternoon, everyone. So in today's lesson, we already learned about the concentration of solutions, as well as percent by volume and percent by mass. And today, I will introduce you to one of the virtual lab that you can use to learn more about concentrations. So here you can just type the Phet Colorado on Google. You can access it from your phone or from your laptop. And you can just click here at the University of Colorado filter. And in this website, they will show you the simulation. So in this virtual lab, it's not only for chemistry, but also for other subjects like physics, biology, earth science, and so on. You can just click the simulations. And then for now, we will learn about the concentration. So we will choose chemistry. In this simulation, you will find some simulations of virtual lab that you can use. So here have making wave, building molecules, until you can also calculate the pH, acid base, and so on. But you can just scroll down until you find concentrations. And you can just click this triangle button to start the simulations. So you already have all the tools that you need for your simulations. The first tab here is to add water, and the tab below is to drain the water. In this box, you can evaporate this solvent that you use. you have a beaker glass with a measurement, and it's already filled with half liter of water. So in this virtual lab, you can only use water as your solvent. And then in this box here, you have a box for the type of solute that you will use. You can just click the triangle here to show more. So you have during mix until the sodium chloride. So you have various types of solute that you can use for your experimentations. So we also have types of solute that you can use here. You can use solid phase or the solutions. But for today's experiment, I will use solid because in class we use powdered juice, which is solid for our demonstrations, right? And this box will show the concentrations of the solution that you have made. First, here you already have half a liter of water as a solvent. First, you need to make sure the concentrations of your solvent. You can just drag the measurement here, and then the number here shows the concentrations. It is a little bit different with the percent of volume and percent by mass that we learn in class today, because the concentrations you will learn in the next grade for better learning. But I will introduce you now so you can learn more about concentrations. We already make sure the concentrations of our solvent. Now I want to add a little bit of solute. I choose drink milk with the solid phase. I want to add just one shake of drink mix. Here, just one shake. You can see the changing color of the solutions, just like what we have in our class today, right? So, and then we can measure our solution here and we get 0.180 mole per liters. This is the concentrations of our solutions. It means there are 0.180 mole in 1 liter of solutions. So what if we add more and more drink mix into our solutions? We already know that if we add more and more, then the solutions will reach the saturation point and the solutions became saturated. So let's try this. I can just add more and more drink mix into the solutions, and you can see the changing color of the solutions. It gets darker and darker the more drink mix I add. Here, you can just add more until it's saturated. So in this virtual lab, they will tell you when the solutions is saturated. So let's try to measure the concentrations. Here, the concentration shows 5.960 mole per liters. And what if we add more drink mix into these saturated solutions? We already know the theories that if we add more, it will become supersaturated, which means no longer drink mix will dissolve in the water, but it will start to make a precipitate on the bottom. You can see here it start making precipitate. So let's try add more. You can see that the precipitate is also getting more and more. And then let's try to measure the concentrations, if the concentrations is different or not. The concentrations is the same because the water or the solvent here can no longer dissolve the solute, which is the drink milks here. And what will we do if the concentration is too saturated or supersaturated? We can add more solvent to dissolve the precipitation of the drink milks on the bottom. So we can just try to add more water here. And you can see that the precipitate here is dissolved because we add more solvent into the solutions. So let's try to measure the concentrations of the solutions. And you can see that the concentrations is decreasing because we add more add more solvent, so the solute here will dissolve the concentration from 50 mole per liter 635 mole from the Phet Colorado. You can try other solute for your experiment in your home, on your phone, or on your laptop. So you basically everywhere.